All right, so we're going to talk about rational functions in this unit. So the first thing we're going to go over is multiplying and dividing, because those are the simplest operations that we can do with rational functions, believe it or not. So a rational function is in the form of p of x over q of x, where it's a polynomial over a polynomial. So some x to some power and x to some power function. And the big thing is that the denominator does not equal 0. So here are some examples of what a rational function looks like. So 3x plus 1 over 2x plus 3. 2x squared plus 3 over 5x plus 1. 1 over 3x plus 1. So the first thing, let's just practice simplifying these normally. So number 1, let's do 24x to the 7th, y to the 3rd, over 56x to the 4th, y to the 10th. We kind of simplified these a little bit in our last unit, except they had like a square root over them, and now they don't. So what I'm going to do is I'm going to find a number that goes into both 24 and 56. So I'm going to reduce this fraction part. So the biggest number that goes into both of those is 8. So I'm going to divide them both by 8. So when I do that, on the numerator, I'm left with a 3. And on the denominator, I'm left with a 7. And I can't reduce 3/7. So then I'm going to look at the x's. Remember, when we divide variables, we subtract their exponents. So x to the 7th minus x to the 4th would be x to the 3rd. And since it's positive, it'll go on the numerator. And then y to the 3rd over y to the 10th. 3 minus 10 is negative 7. So since it's negative, we'll put y on the denominator. So we'll have y to the 7th on the denominator. Can't simplify this fraction anymore, so this will be my answer. All right, number 2, I would like you guys to try. So let's do 42x to the 5th, y to the 9th, 35x to the 7th, y squared. So I'd like you guys to try these. So go ahead and pause the video. All right, so for this one, you should have gotten 6y to the 7th over 5x squared. You reduce 42 and 35, you can reduce by 7. When we subtract our x exponents, we get negative 2, so x goes on the denominator. Subtract the y exponents, we get 7, so that goes on the numerator. All right, so now let's look to see if there's adding and subtracting between our terms. So let's do x squared plus 7x plus 12 over x squared minus 16. Now here, because of our adding and subtracting in our polynomials, we can't just cancel out. Okay, when we're canceling out fractions, it's because we're multiplying. So we can't just cancel out these x squareds and reduce that. So what we're going to do is we're going to factor each piece. So the numerator, when I factor, these factors sum, because we have a trinomial where a is 1. So I'm looking for factors of 12 that have a sum of 7. So two numbers that multiply to 12 and add to 7 would be 3 and 4. So my numerator would factor into an x plus 3 and an x plus 4. Now the denominator, when I factor this would be a difference of squares because I am subtracting two perfect squares. So remember when we do our difference of squares in our parenthesis, we do 1 plus and 1 minus. So this would be x plus 4 and x minus 4. Now the x, what we're going to look for now is, like in the numerator, when we're multiplying terms, we can cancel out on the top and the bottom. So here we're multiplying factors. I'm multiplying x plus 3 and x plus 4, and x plus 4 and x minus 4. So if I have the same factor on the top and on the bottom, I can cancel those out because they divide to 1. So here, I can cross off an x plus 4 and an x plus 4. So I'll have x plus 3 over x minus 4. And I can't reduce this anymore, so this will be my answer. So number 4, I would like you guys to try. So we'll do x squared minus 2x minus 8 over x squared minus 9x plus 20. So go ahead and pause the video and try number 4 on your own. All right, go ahead and check number 4. Both of these were factor sum problems. So for our factor sum, we get x minus 4 and x plus 2. Forgot this parenthesis here. And then an x minus 5 and an x minus 4. And then we have x minus 4s that we can reduce. So we divide the top and the bottom by x minus 4. So that's reduced to 1. And then we're left with an x plus 2 over x minus 5. All right, let's try one more just simplifying. Let's do 2x squared minus 7x plus 3 over x squared minus 5x plus 6. So now the numerator method of factoring we're going to use on this, there's a 2 in front of my x squared. So I can't GCF any of this. And there's a 2 in front, so I'm going to use either SAM or factor by grouping. So I would multiply 2 times 3. So I find factors of 6 that have a sum of negative 7. And those two numbers should be negative 6 and negative 1. And with SAM and grouping, it's easier sometimes to do the work off to the side and then come back and put it together. So I'm going to finish this work off to the side over here. So I split my middle term, 2x squared minus 6x minus 1x plus 3. And then I will group them and factor out the greatest common factor from each. So for my first parenthesis, it's a 2x, which leaves me with an x minus 3. And my second parenthesis, it would be a negative 1, which would leave me with an x minus 3. Remember, you always want to take the sign of the first number, so there's nothing that's going into 1x and 3, but because this 1x is negative, that's why I'm factoring out a negative 1. So that negative 1x divided by negative 1 is x. 3 divided by negative 1 is negative 3. So then this would factor into an x minus 3 and a 2x minus 1, because we would factor out an x minus 3, and be left with the 2x minus 1. So that is this one, x minus 3, 2x minus 1. And grouping and SAM are really the only ones you kind of need to work off to the side a little bit. The denominator here, we're going to factor using factor sum, because it's 3 terms, and the number with our x squared is 1. So I'm looking for factors of 6 that have a sum of negative 5. So two numbers that multiply to a positive 6 and add to a negative 5 would be negative 2 and negative 3. So this factors into an x minus 2 and an x minus 3. And then we look to reduce, so the x minus 3's can cancel out because I have one on the numerator and one on the denominator. So I'm left with a 2x minus 1 over x minus 2. All right, and so now we're going to move on to multiplying these together. So number 6, let's do x squared minus 5x minus 14 over x squared minus 3x plus 2 times x squared minus 4 over x squared minus 14x plus 49. So our first step is we are going to factor each numerator and each denominator. So you can see why we spent so much time reviewing our factoring skills. So this top left one, x squared minus 5x minus 14, we're going to factor using factor sum. Factors of negative 14 that have a sum of negative 5. Those two numbers are negative 7 and positive 2, so x minus 7 times x plus 2. On the denominator on the left, we're going to do the same thing. I'm going to factor sum it, but here I'm looking for factors of 2 that have a sum of negative 3. So two numbers that multiply to 2 and add to negative 3 would be a negative 2 and a negative 1. Times, I'm going to do a similar thing on the right-hand side. I'm going to factor. So the numerator, the x squared minus 4, would factor into using difference of squares because we're subtracting two perfect squares. And so this would factor into an x plus 2 and an x minus 2. And the x squared minus 14x plus 49, I would factor using factor sum. be looking for factors of 49 that had a sum of negative 14. Those two numbers would be negative 7 and negative 7. So x minus 7 and x minus 7. Right. Now when we multiply fractions, so say I had like 2/3 times 4/9. You multiply across. So we have 2 times 4. A lot of times you don't write this out. So we'd have 2 times 4 over 3 times 9. And then we'd just multiply it. So a lot of times you'll just go straight to 8 over 27. Now, same thing here. We have a fraction and we're multiplying these two. So really I'm multiplying these numerators and multiplying our denominators. So what I like to do instead of having to rewrite it again is I just make it one big fraction. And now it looks like our simplifying ones. So if we have something the same that's on the top and on the bottom, we can cancel them out. So it looks like I have an x minus 2 on the top and on the bottom. And I have an x minus 7 on the top and the bottom. There's nothing else that will cancel. So on the numerator, I'm left with x plus 2 squared. I'm left with 2 of them. And on the denominator, I'm left with an x minus 1 and an x minus 7. All right, so let's have you guys try one. You guys try x squared minus 1 over x squared plus x minus 6 times 2x squared plus 7x plus 3 over 2x squared minus x minus 1. So go ahead and pause the video and give this one a try. Pause the video and give this one a try. All right, go ahead and check your answer. So on the top left, we use factor sum, we use difference of squares, and then factor sum. Both of these were SAM, or grouping. So again, with those, you kind of need to do the work off to the side. So I did the work off to the side. If you need to pause it to see what the work is, go ahead, feel free. And then you cancel out like terms on the top and the bottom. So I just underlined them so I wouldn't cross them off so you could still see them. And we're left with an x plus 1 and x minus 2. All right, so the last thing that we will go over is dividing. So number 8, let's do x squared minus 9 over x squared plus 5x plus 6 divided by 3 minus x over x plus 2. So now with fractions and dividing, there's a pattern to what we do. So let's go back to, I think we did 2/3 divided by 4/9. So 2/3 divided by 4/9. Whenever we divide fractions, we keep the first one the same, change it to multiplication, and then flip the last one. And now it's a multiplication problem, so we could do 2 times 9 over 3 times 4 and reduce this. So we're going to do the same thing when we're dividing rational functions. We will keep the first one the same, change the middle term to multiplication, and flip my last fraction. So I'll get x squared minus 9 over x squared plus 5x plus 6. Change to a multiplication, and flip our last fraction. So now it's just like our multiplying. So we're going to go ahead and factor each one. So the numerator on the left-hand side, this is a difference of squares. So it'll factor into an x plus 3 times an x minus 3. The denominator on the left is a factor sum, so we're looking for factors of 6 that have a sum of 5. Factors of 6 that have a sum of 5, that'd be 2 and 3. X plus 2 over x plus 3. On the right side, I can't really factor x plus 2. That's going to stay x plus 2. Now here we have a 3 minus x. So a 3 minus x, what I'm going to do is factor this using GCF. And yes, we could leave it. However, we like our x on the left-hand side, so we cannot just flip it. So if I factor out a negative 1, this is negative 3 plus x, which is the same thing as negative 1 times x minus 3. So factoring out a negative lets us flip the subtraction. So when I factor out a negative 1 here, I'm allowed to flip x minus 3. And what that'll do is it'll let us cancel out with x minus 3 up here. So we'll make it one big fraction and cancel out terms. So let's see, I have an x plus 3 and an x plus 3 that'll cancel. An x minus 3 and an x minus 3. An x plus 2 with an x plus 2. So I'm left with, when everything divides out on the top, I'm dividing everything, so this will divide out to a 1. On the bottom, I'm left with a negative 1. So this is just negative 1. All right, number 9. I'm not going to solve number 9 all of the way, but I'm just going to show you something that you could do with it. So 4x squared over 9. To be honest, I didn't like the way I wrote this. 4x squared minus 9 over x plus 4 divided by 6x plus 9 over 2x squared plus 5x minus 12. So these are something we call complex fractions. It's basically a fraction within a fraction. So what we can do is we can take our big term and change this to a divided by. So I would get 4x minus 9 over x plus 4 divided by 6x plus 9 over 2x squared plus 5x minus 12. And now this is just like the previous one where we can keep, change, flip. I'm not going to solve this one out of the way, all the way, just for time's sake. But if you have extra time and want to try it, I suggest it. And give yourself some practice. The answer should be 2x minus 3 squared over 3. All right, so come see me if you guys have any questions. Have a good day.